Amy is wanting to rent a car, and there are 3 places she can rent it from, but she doesn't know how many miles she's going to drive. Each place gives her different rates, different mileage allowance, and they give her different monthly costs. We're trying to find out the least expensive option. That's called a payoff table. And the way I filled this in is that I checked first to see if the expected mileage was greater than mileage allowed. If the mileage allowance is greater than or equal to the expected mileage times the number of years, then the expense is just the monthly cost. So basically, if you stay under the allowed mileage, all you have to pay is the monthly cost. If you go over the mileage cost, then you have to pay the monthly cost plus their cost for additional miles. I worked out in an example here. Looking at Midtown, let's say she expects to drive 18,000 miles. 18,000 miles times 3 is greater than Midtown's allowed 45,000 miles. She goes over the mileage allowance. That means we have to use this formula. The monthly cost for Midtown is $310. It's a 36-month lease. She expected to drive 18,000 miles each year for 3 years, because 36 months is 3 years. The difference between the mileage allowance and the miles she actually drove is how much she went over. Multiply that amount by the cost per additional miles. For Midtown, it's 20 cents. That costs $12,960. Midtown, 18,000 expected miles driven each year is going to cost $12,960. And so I used these 2 equations to fill in all of this. After you do that, to find the expected value, we first need to know the probability of her expected miles. Part A says she's unsure. I assumed that to be an even distribution. To find the expected value, let's look at Honda. So the cost for 12,000 miles times the probability plus the cost for 15,000 miles times the probability plus the cost for 18,000 miles times the probability gives us 12,000. We do that for each car place. We see that Hopkins is the least expensive. Part D goes over expected value, so we'll get more practice with that. Part B, they want us to make a payoff table, which is basically what we did in Part A in order to solve Part A. And so that's just the inside part. That's right here. That's our payoff table, also known as a decision table. These top options, those are sometimes called states of nature or outcomes. These are the decision alternatives, and these are called the payoffs. They can be profits, costs, distances, or times. In this example, they are costs or expenses. We're not looking for the highest value, we're looking for the least expensive. If these were profits, then we would want the highest value. Looking at Part C, now we have different decision-making approaches. One approach is the optimistic approach called Maximax. We're trying to maximize the max value. The Maximin, or the conservative or pessimistic approach, we're maximizing the minimum value. And the mini-max regret, we are minimizing the maximum regret. First part, the Maximax optimistic approach. Looking at our decision table, here the best option for Honda is the cheapest value right there. So I wrote that down. And the best option for Midtown, either one, they're all the same for Hopkins. And now we're taking the best out of the best. For the Maximax approach, we would choose Honda. Now for the Maximin, this is the pessimistic. That means worst case scenario. Worst case scenario out of all these, you pay the maximum. 18,000 miles, 18,000 miles, and any of those. You can see those values here. And then we're taking the best value, the least expensive, and this one's Hopkins. So regret. Another name for that is opportunity lost. For instance, if you go on vacation, you think of the expense that you're paying for the vacation, but there's also the opportunity loss would be the amount of money you miss out on by not going to work. So if you made $1,000 a week and you went on vacation for a week and the vacation cost $500, the total cost, including the opportunity loss, would be $1,500. $500 for the vacation, $1,000 lost from not going to work. That is calculated by the best payoff minus the payoff received. Like I said, the best payoff doesn't necessarily mean the highest, so I put absolute value bars around it. So if I chose to rent a car from Hopkins, the better option would have been Honda, so I would have missed out on $936. For 15,000 miles, the best option would have been going with Midtown. If I had purchased a car from Honda, I could have saved that amount if I'd gone with Midtown. And I could have saved $540 if I had gone with Midtown instead of Hopkins. Again, you take the best option, subtract all three, and the absolute value of that. We don't know how many miles we're driving. We don't know the future. We're just taking these into account. Looking across this way now, the worst option for Honda, 1,764. Worst case scenario for Midtown, 1,260. Worst case for Hopkins is 936. We're minimizing the maximum regret. So the maximum regret, that's what those represent. And then minimizing that, Hopkins is the best choice. Part D, we're looking at expected value again. I rewrote the payoff table. Expected value takes probability into account. Amy thinks there's a 50% chance that she'll drive 12,000 miles, 40% chance that she'll drive 15,000 miles, 10% chance that she'll drive 18,000 miles. So if she purchased a Honda, there's a 50% chance that she would pay this amount. So I wrote 50% times that amount. 40% chance that she would pay this amount, and a 10% chance that she would pay this amount. This is the value that she could expect to pay if she were to choose a Honda with these probabilities. Now part F is the same way, given different probabilities. So she thinks it's more likely that she'll drive 18,000 miles. We can expect the expected value to go up because the expense for driving 18,000 miles is more expensive. As far as the formula, you're basically multiplying each alternative cost times the probability and adding it up. Looking at these probabilities, these are the expected values that I would pay. And so it's obvious that the Midtown car will be the least expensive. And with these probabilities, I have two options. I don't think that's correct.
Thanks for watching. If you need help with math or physics homework, email me at swinson.university@gmail.com.